So hello everyone. I'm going to start with I'm going to continue our discussion on Hive. Okay. So yesterday we were talking about Hive. Hive basically is a tool which bridges the gap between the SQL and your big data. All right. So Hive provides you SQL query interface and that you can use with which you can query the data just like the way you used to query the data from database. Standard database. All right. So I'll just go over quickly. So we talked about how to connect to Hive. So you can SSH to hadoop1.nobigdata.com and type Hive and you can start working on it. All right. So as I demonstrated yesterday, is the screen visible clearly? Is the font visible? So right now I'm typing student SSH student and I'm saying Hadoop one dot nobigdata.com. All right. So this is how you start, and then I talked about how to execute commands from Hive. Data types are there, complex and normal data type, along with so they're similar to MySQL. You have a concept of databases, and and then we'll talk about the tables. Okay, this is something which I did not discuss yesterday. So every database has got two kind of data. One is metadata. Metadata is like what columns are there, which databases are there, which table is in which database, and what is the data type of each column in a table. So all of this is called metadata. So metadata is not stored in HDFS, while the actual data, the data is in the row, is stored in HDFS. All right. The metadata is stored in something called metastore, Hive metastore. By default, Hive metastore is a normal database, like Derby is there, but you can configure it to store this data in your MySQL. You can configure it to do that, and so the I mean when the load increases, then you generally move it to MySQL from the default one. So, but for time being, we'll just continue with the Hive metastore. Okay, Hive metastore stores the metadata. Okay, it's just a small, tiny database which runs on the same machine which runs on one of the machines on the cluster. Right. Now let's go ahead and all right. So we talked about something called manage tables. Manage tables are the default tables. So before you start working on your data, you need to first create a table to represent what does your data looks like. So we had so the now recap is over. Now I'm starting again with this point onwards. All right. So before you start working on your data, you need to first define a table or you need to first define the structure of the data. So for example, we talked about NYSE daily earlier, in which we had our data which was tab separated format. Okay, so I'll just show you. the data we have the data in this location. Okay, let me open one more window. Okay, um all right, now I'm connected to the hadoop 1.nobigdata.com, and I have opened two sessions. In one I am running Hive and other is the command prompt empty. So here, for this exercise purpose, I have kept the data in asgiri Hive. So let's have a look at what does, I'm just doing a tail gives you the last few 10 lines. Right. So this is how our data looks like. We intend to analyze this data. So it's a data from stock exchange. First one is the name of the first one is the name of the stock exchange. Second one is the symbol. Third one is the date, open value, close value, and all that. Okay. Open, high, low, close. Open, high, low, close, and then we have volume and then price. All right. So so we have got this kind of data, and we might require to do a lot of churning of this data, right? So before starting, we first define a structure of this. All right. Let me just first drop that. So let's create a database for this session. Create database called 6 December, and all right. Now I'm using that database for the discussion from here. All right. Now we have got this table called NYSE daily. All right. Now what does this table say? Table says the create this table with these columns and this data type, and the row format. We define how the row formats, I mean, how is the data stored, so that whenever we are querying this table, this format will define how to read the actual underlying the data. Okay, the data which is uh, I mean the table, this table is basically a representation of the actual data, which is going to be tab separated. All right, and this is the location where our data is going to be stored. The actual data of NYSE daily is going to be here, and this is not the place where the metadata will be stored. This is the place where the normal data is going to be stored. All right. Meta store you do not define, but location where this file is going to store this data will be stored here. All right. And if we do not mention this location will be somewhere in the app Hive meta store. Okay. For timing, let's just remove this. Okay. Let me just remove this. Okay. And we can we can basically drop table now. All right. Now to check what does our table looks like, we say describe formatted and NYSE daily. Right? This shows you the detailed information about your table. All right. It shows you what are the columns there, what exactly, where is this data stored. You can see this. So here is your, okay. This is where your data is going to be stored for this one. Right. Now let's have a look at it. So this is our HDFS location, and Hadoop fs minus ls. If you have access to if you have access to the hue, you can also check it there. Okay, so right now NYSE daily is just a folder. It does not have any data inside it. All right, so the moment we created this table, i- Hive created a folder where it will be putting the data related to a particular table. Okay, so each table refers to a directory in the physical place. Okay, right now it is empty. So the next step is that, all right, so although for the purpose of the discussion, let me leave it the way it is. And right, so now the next step is, let's load this data, the data which I showed you earlier, this data, this data. Let's load this data onto our table. Okay, so the way we load the data from a local file, we say load data local. Remember local here. If you say local, it means you're copying the data from a local folder to Hive. Okay, local with respect to from where you're running this command. Okay, so there are three places. One is your desktop from which you have done SSH to these servers, to Hadoop one, and second place is that the Hadoop one, and third is your HDFS. Okay, so local here refers to Hadoop one, right? So our file is lying in the local file system of Hadoop one, and we are saying load this data which is located in this path. All right, this is a local structure. Okay, so I mean the way you can say that, the in Linux the home folder of student is home slash student, while the home folder in HDFS is slash user slash student. Okay, now so this loads our data. So what is, okay, load data local in path. Mismatched token into, actually you have to write into also, into n NYSE daily, into table actually. So it says overwrite into table. If you don't, so as you can see that the data was first copied, copy data from this file to HDFS, and once that is done, the data was loaded. Okay, all right. Let me have a look at the question. What is the command to get the location? Mm, no, I was actually explaining that the home slash student is actually local file system on which I'm running the Hive. Right. So Manish, as you can see here in the command, okay, actually, which part did you miss, Anna? So what is the command to get the location? To get the location, you have to say describe formatted, and then you say table name. Okay, so it will give you the whole detail about where the data is going to get stored of this everything, including everything about this table. You can see if you say describe formatted, describe space formatted space table name. All right, Anna, good, good. And all right, let me have a look at Manish's question. How does it know which table to load data to? If you can see the, is my screen visible? It says load data, local in path, and then NYSE daily, and overwrite into table NYSE daily, right? So we are saying overwrite the data, okay? If you don't say overwrite, if you don't say overwrite, then this table called NYSE daily will be appended. All right. So whenever you're copying the data from local to the table, whenever you're loading the data from local, the data is always copied. While had this file been on HDFS, we would say load data in path. We'll omit local and then we'll give the HDFS location. In that case, this HDFS file will be moved. Okay, it's a design decision taken by Hive guys, where if you try to load the data from HDFS, it will actually move the data, move that file to the Hive location instead of copying it. Right, right. You're right, Vishnu. Append is definitely possible. Only the row level updates are not possible. You're right. Yes, Abhishek. Abhishek's question is, aren't there any constraints, unique constraint? No, there are no constraints. There are no constraints at all. And even indexing is very rudimentary. I'll talk about indexing a bit. All right. Yeah, definitely there are duplication possible. But when we deal with the big data, duplication constraints, foreign key are not the the concern. The problem generally is how do we churn the data. So Hive's main intention remains that how can it make it possible to churn the data. All right. And Hive doesn't manage any data. Hive just manage this metadata. So Abhishek, you can write to all, not only to me. Okay, so that I don't have to repeat the question. It is more of denormalized data that we are processing here. Yeah, you can say that, yes. But it's okay. Here also you can opt for normalized data. You just have to join the data, and joining is possible in Hive. All right, that would not be a problem even if your data is normalized. Even, that will not be a problem. Good, good. So we are all on the same page. And in case same file, let's now we have loaded the data. Let's just check if the data is loaded. NYSE daily. Okay. Select star from NYSE daily. It's working fine. Great. So now we can do things like select star. We can do a lot of things here. You can write standard query. And the data I forgot to show you. Same place. If we do this now, you will see files here. So you can see NYSE daily has been copied into this folder. Okay. So no format will be changed. NYSE daily. Okay. Can I just see? All right. Let me just do a tail. I don't think tail is also there. Good. So you can see it's the same file which has been copied to apps hive warehouse 6 December New York Delhi. All right. Yeah, this is there in the presentation, and the presentation is shared with you. Okay, so you can download that presentation and start using that one. Now, so this was how you load the data from local. If you are now let me just drop this table. Okay, let me drop this table. Drop table NYSE daily. Okay, so if you look at it, it is no longer there. The data would be deleted by now. No such file or directory. Alright. Now let's just create the table again. We'll have to create the table again. We could actually do a truncate instead. Good, good. Now this table is created again, and this time what we are going to do is we first copy data from local. So let's just copy the data from local to Asgiri, which was our folder there. Okay, let's copy this NYSE daily. Okay, so we are copying the file from local to HDFS. So, all right. Now the next step is that let's check if it is copied or not. Hadoop fs minus ls Asgiri, and so the file is there. The next step which we are going to do is we are going to load this file. All right. We say load data in path. See, we have not put local this time into table New York. Okay. Also, the syntax is not case sensitive. Okay. So you can write either in caps or lower caps or camel case or whatever. So, so whatever the keywords are there, those are not case sensitive. All right. So let me just try to load it. This time it has moved our file from this location to this location. Okay, which means that this the one which we copied will not be there anymore. So it says no such file or directory. All right. And now again at the same location as earlier, we have got it has moved our file to that location. So let me first do ls. All right. Oh, I think it has. Okay, this time it has done a different thing. It has done this. Let me have a look at it. Describe formatted. Describe formatted, and I say NYSE daily. It should tell me where exactly. So it is showing me that the data oh right, this time because we had mentioned that location of the data is going to be this, so our all right, all right, so it is there. Okay, so the file has been moved to that particular location, and that's all. Overwrite is not necessary. Overwrite is not necessary. It's just a syntax we have moved. If you don't put overwrite, it will be fine. All right. Now, so what we did just now is we created a database table, and then we tried to load the data from local file system as well as from the HDFS. We also tried to demonstrate what happens in case we copy the data from local and load the data from local, because in case of local the first is file is copied, while in case of HDFS the file is moved. All right. Now here there are a few more things to note. In case you do not define row format as /t, the default format it expects it to be control A. So control A should be separating your columns in the file. If you do not define it as /t, okay, or comma or something else. The next one is, all right. So rest of the things we have discussed. Also, there is a concept called partition. For each set of data you are loading, you can load in different files. We will discuss it quickly in a minute. Right. And since now our table is ready, we can do we can start running our queries. All right. So now it has started running the queries, and we can run a lot of other queries also. Okay. So it shows you that it is running the query for you. And it's actually the standard map reduce, and it gives you the tracking URL also to see what's going on. It also, so here we were able to filter out our records based on a particular value. All right. Now we could do a lot more things over here. All right. Good. So the data is located at this location, app hive warehouse. If you have not mentioned the location, and in case you have mentioned the location in the table, then you will see at that location. In our case, first we did not mention the location, so the the data was created in apps hive warehouse on HDFS. Okay, so this is on HDFS. Okay, or we can define our own data. Again, the location should be on HDFS. All right. Now that was about loading the data into a table. What if we want to download the data back into the file system? So what you do in those cases is you say insert overwrite local directory, and we define our local folder name, and then it basically we run the query. We say that this is my query, and it saves the data there. Let's, all right. right? So data has been copied to slash tmp, okay, and can see that. And by default, it saved it with Control A. You can see that because we did not define the partition. We did not define the way it has to save the data. Okay. Now, if we had mentioned the separator to be comma, it would save it as comma separated. Okay. And in case we want to save it on HDFS, we can save it onto HDFS. Right. So Abhishek, your question is that so how do we import our data from relational database to HDFS or existing database? So if you're moving your data from relational database, then you use tool like Scoop. We will go through Scoop in a very, I mean, in one of the sessions. Okay. So Scoop will suffice for most of your needs in that case. Okay. Now this time it has saved onto the HDFS. So I'm querying HDFS to check if it is there. So it has been put over there. All right. So again, that has been copied onto the file system. All right. So we were able to download the data from table to the file system based on a query. Okay. So there is a concept called partitions. A table can be partition table or table can be normal table. If the table is partitioned, the data will be stored in different files. Each partition means a different partition means a different file. Right now, when we imported our NYSE stock exchange data, there was only single file that was storing the data. Okay, but in case you want to separate the data based on various while importing the data, so that so that for querying a piece of data, for querying a section of the data, you do not need to scan the whole file. Okay, now imagine this: if you have got 100 GB file, and each it has got basically your role involves querying data based on a certain parameter. It would make sense to divide this whole data into separate files based on that particular parameter and keep it in those files. Okay, and whenever we want a portion of this data, we just look at only that particular file con- um, containing that portion of data, right? So it sort of eases your life a bit. You don't have to scan the whole data. It basically makes your query faster, right? So in very simple words, to avoid the full table scan, instead of instead it does the partial table scan. Okay, the data is stored in different files based on the various combination of the values of column. So basically what based on how you have defined your partition table. Based on the column on which the table has been partitioned, for each combination there will be a separate file. Okay, so if we have defined our table on symbol, so for each symbol I'm talking about the previous table which we talked about, for each symbol we'll have a separate file. All right, or if we had defined our table based on two columns called stock exchange and a symbol, then for the all combinations of symbol and stock exchange there will be different set of files. All right, and while defining table itself, you have to mention like partition this table by this particular column. Okay, in the create table itself. All right, so you can also do a add partition later on. Okay, but you have to define that your table is partitioned by these data. Okay, and each partition can stay in a different folder, and while doing add partition you can add a different set of files. You'll see, don't worry, you'll see it quickly. Let's have a look at a simple example of partitioning. Okay, now let's say that we have a table called the emp, and this is located here, cat the emp. All right, it has got only two rows. Okay, it has got only two rows. So okay, so this definition says that create a table called employee having three columns in it and partition that by qualification, and the row format is comma because this is what we have here. Okay, now let's go back to Hive. Done. And then we also, let's just create one more file called the amp. Okay, cp the emp, and okay, and let me just edit it for time being. All right, so next step is that we first check how does our table looks like. I'm going to the Hive now. So this is the detail of the table, and our data is stored in employees under this folder, and this is a managed table. Now the next step is, sorry, I'm doing it the wrong place. Okay, Hadoop FS, you can see, not this way. We say 6 December dot db. All right, so there is no data as of now, but the folder exists. Now let's load the data first. So we are loading our file the emp into employees, and based on this. Okay, now let's see if get loaded. Yes, it is loaded now. And if we see select star from employees, and we have this. Okay, and all right, and you can see that what does the syntax say? It says load data local in path into employees. Partition is qualification equals to 1. Okay, so qualification is essentially a column now. Qualification is essentially a column now here. Okay, all right. So now you can see that there is a fourth column also over here, which is essentially the one which is defining the partition. Okay, now let's load the second file also, and we could give it a name called qualification. Select star from employees, and what do we have? Okay, so we have got now two tables. Okay, oh, we have loaded different data. Okay, so what did we load? We loaded the EMP1 from somewhere else. Never mind, never mind. So here, so we loaded two different data sets. We marked them with a different column name, which is basically a partition. And now you can see here there are two folders. One is qualification equals to 1 and other is qualification equals to 2. All right. Okay. So Manish is saying, see, can we do such thing like we can partition the data by name so that Sandeep goes to one file and Shravani goes to different partition. Okay, that's a good point. The thing is that Hive doesn't seem to provide this kind of functionality. I was also looking for this, that if we mark that partition by this and we insert the data, and it should automatically partition it. But Hive doesn't seem to do that. Hive only provides you the manual way of partitioning. Okay, so we basically manually defined that our partition is this, and we loaded the data into that partition. But good point is that we can now say select star from employees where qualification equals to 1. All right, or 2. So now only one of the file is getting scanned at a time. So there are two files you can see. So under employees folder, it has created a file called qualification equals to 1 and qualification equals to 2. Right. Can we have partition on composite key? Yes. 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 So we can actually do and what is name equals Sandeep. So from the query perspective, partitioned column behaves like a normal column. Okay. So you can do all sorts of things, like you can query on existing column, partition column, combine them together, and then query. Okay. Yeah, Abhishek, from storing perspective. So I was actually answering Manish's Anna's question. Yes, can we do where on other columns? Exactly, and you can also combine. select star, let me do describe employees. Okay, and select star from employees where name equals to Sandeep. Okay, also you can see that when there is no group by or sorting required, there is no reduce task. There's only one mapper. Okay, alright, so you can see this, and we can say qualification. So as you can also see that there is it's a batch execution of the work, which means it is going to take a little bit of time. There is a boot up time involved. Therefore, you do not use. So you saw that we were able to query based on name as well as qualification by putting an AND operator, right? Okay. So let me answer. Yeah, Abhishek. Yes, we can have a partition on composite key. Okay. So while defining here, we could just put one more comma saying qualification equals to 1, comma something else equals to this. Okay. So then you will have separate table for the all combinations of the two values. All right. Can a particular column be on one file and a different column is in different file? No. So partition is based on the rows, not on the columns. Okay. So for the cases in so basically the Hive or any of these things, mostly they are concerned mainly about rows. Okay. Their assumption is that column number of columns would not grow beyond a certain size. All right. It's only the databases such as HBase who handle millions of columns. Okay. There the partition also happen based on the column names. Okay. So some column go to one, some other column go to elsewhere. All right. So that is what we call as partitioning, partitioning of a table. All right. And similar to your standard SQL, these are data definition language. I mean, data manipulation, we call it alter table, update table, this, that, that is called DML. Sorry, not alter table. When we are insert into database, update a particular table or delete the data, query the data, that is data manipulation. Is DML. While when we define a table, alter columns or add more metadata, that is called DDL, data definition language. So we can change the column name, table name itself using alter table, and then we can also do change the change the column data type also. Okay, we can also change, we can add more comments to it, we can change the name of the column, we can also add columns at later point of time. Also we can drop a particular partition. So in case we have got a table called log messages and there is a partition for this particular data, okay, for this particular combination where year equals 2010, month equals to 12, and day equals to 2, that partition will get deleted. Okay, so we can also do all sorts of things there. So not really. The partition is actually done on any field on which you want to query very frequently. Just like you create indexes on the standard database, similar to this, if you have the data fairly, you know, has more chances of query. If you're querying your table very frequently on a one particular column, or you are querying your data on those two columns very frequently or three columns very frequently, you generally partition your data based on those two columns or three columns or that column. Whatever on whatever, basically you can think of partition like index, okay, but I mean where your each bucket is going to be separate, is in the separate folder, okay. Now on top of it, give me a second. The other optimization step Hive provides you is something called bucketing. Okay, bucketing is defined by cluster by. Actually, in cluster by you don't require this. Okay, let be there for time being. Okay, so here we are saying that we have got a table called page view. These are the columns, and we have also put some comment, then partitioned the table. Also, we have clustered the table. What does it mean by cluster? Cluster means that cluster means that we have divided the all the data into 32 buckets, okay, based on user ID. So, if your user ID is going from 1 to 320, okay, each of the bucket will be containing 10 user IDs each. All right. So these are basically the buckets created based on your user ID. Okay. Which means that in case you are querying on a particular column called user ID here, that means you will be only scanning few buckets rather than all buckets. Rather than whole table, you will be only scanning few buckets based on what user ID you're looking for. Say you say user ID greater than 1, less than 10. That means you will be only querying one first bucket. Okay. So let's say there are 320 user IDs. And since there are 32 buckets, which means each bucket will contain 10 user ID, 1 to 10. And whenever you're querying, saying bucket, select star from page view where user ID is between 1 and 10, okay, that means we'll be querying only one bucket, and there will be only scanning of that file for that bucket, right? So that is what we meant by bucketing. Other than other than clustering, so each cluster will contain the data sorted by that user ID. And also we can also define another parameter for sorting. Okay, so sorted by each bucket will further be sorted based on the time. Alright, so that was bucketing. Now, other than the manage table, so far we talked about our internal table. We can also define a table like as external, there is not too much of a difference between a managed table and an external table. The only difference is that data is not owned by Hive. So data is not owned by Hive in case of external table. When you drop an external table, the data remains as such. Also, an external table can lie anywhere. While managed table will only be in HDFS, external table can lie anywhere. External table can also be in a remote system. It can be in S3. It can be on any network partition. So that is the only difference between external and the managed table. So we can actually define it like this. So we are defining a table called my stocks right now. All right. We're defining a table called this one. And and you will be surprised that in case you say my stocks, select star from my stocks, it already has data. All right. Why? Because our other table is storing the data at the same location. Okay. Our other table is storing data at this location. Okay. So Excel table basically created um, is another table pointing to the same data location. All right. Which means there can be multiple tables operating on the same data. All right. S- So on the similar line, we could also create an external table. Like in this case, what we are trying to do is we are creating a table which basically represent an S3. Okay. So every time we will query this table mini wiki stats, it is going to hit S3 URL. Okay. So it just okay. All right. Although it doesn't work, but I'm just keeping it this way. All right. Now N- Now the important part is that every time you're going to query this table, it is going to the S3 and then come back, which means it is going to have a very huge latency. But the good part is in case, say you're querying Amazon AWS public datasets. Public datasets are in hundreds of terabytes. You only want a particular section of that one. Okay. So instead of copying the whole file from S3 to your HDFS, you can start querying directly on S3, and then you can pick up only the data set you want and store on your HDFS if you require. Okay. So that is the main use of these kind of tables where you don't have to copy. All right. So it does provide you all sorts of variables, environment variables to define S3 integration. Okay. Also, the login password you can also define in the URL a at the rate something and then colon. All right. But that's not the concern here. But in case you want to go for the details, you can look at how how to load the data from S3 using using the S3 into Hive. Okay, I don't have a working URL right now, but this is just for the concept purpose. Okay. Similarly, the way we had defined earlier, we can define a external table as partitioned. And good part is that If an external table is partitioned, each partition can be located at different locations. And what do I mean by different location? One could be on HDFS, other could be on S3, and and other one could be elsewhere. Okay. So here in this example, yeah, S3 is basically a service provided by Amazon to store humongous data on AWS. Okay. So S3 is, I mean, I'll show you this. So if you say Amazon public data sets, so all of these data sets are provided to you by the way of S3. Alright. Here it's a dummy URL for the sake of examples. So whenever you talk to S3, you have to provide login, password, login as in key, and then secret key, and bucket name. This is our bucket name. Our bucket slash log slash something. Okay. So, and so in this one, what we have tried to demonstrate that there is an external table which is partitioned by these three columns, and rows are delimited fields submitted by slash t, and then we alter the table, we add partition to it, location is there. We, for each partition we can add more locations as and when we want. Okay. All right, so that was a brief about an external table. Okay, again let's do a brief recap. So each table has got a location, whether local or external. By default, the table is a directory under app hive warehouse. You can always provide the location for a table while defining the table using a parameter called location. The load statement copies the data in case we are loading the local file, and it moves the data in case we are moving the HDFS file, in case we are loading the HDFS file, the, irrespective of whether the table is managed or external. Okay. Dropping managed table deletes the data at the location. Okay. So the moment you drop the table, for example, here we have, if we drop employees, okay, our, okay, so let me just show you this. So we have got employees. So if we drop table employees, drop table employees, the table, the data gets deleted. All right. Now, in case you are dropping an external table, so let me show you Hadoop fs minus ls slash data slash nysc daily. All right. So so in case I am dropping an external table, let's say my stocks was external table, nothing will happen to the data. So data is as is, but in case you drop table NYSE daily, then our data gets deleted. So the data got deleted. All right. So external table does not delete the data. Okay, while internal table manage table dropping manage table deletes the data. Metadata is stored in meta store and is generally the relational database. Does Hive support subqueries? I think it does support subqueries. I need to check that one. Let me make a note. All right. I think it does, but let me first check before I confirm. So I'll let you guys know. I mean, I keep on putting all of these questions on the forum as and when I get something. Okay. So select statements are standard select statement. You can say select uh, star from employees, or you can say select star from this way. Also, also you can do the computation on. So let me see. Do we even have a table right now? Show tables. We don't have. Select star from. Okay, we have actually deleted it. Never mind. So also we can do the computations on the column such as upper, and we also can access a particular. This is our map. We are accessing a particular value from the map, right? And also we are calling a round function. So these are the few examples of how do you call the computations on the column. And then we have aggregations. Aggregation is standard like select count star and from employees. Here these aggregations do not require any you know the reducer per se. And in these cases you can also further improve the performance by telling Hive to do the aggregation on the map side if possible. Okay, when there is no group by statement, lot of things can be done in the map itself. All right, so this is how, I mean, aggregations, you can do a lot of aggregation, even things like standard aggregation functions, something like select star from employees. We can say department and then count. Okay, count names from employees, group by department. Okay, so this is a standard way of calling. All right. Now the next point is that the views are also possible. Okay. So most of the time a view or external table would be sufficient. So on the actual data, you first create your external tables. And once you have done that, you can create a view on top of your external tables and then start working on that. Okay. So view acts like a table only. So basically, for every query, we can create a view that will simplify our way of simplifying our queries. Okay, so we are saying select ID, timestamp, text, country from tweets, and left outer join with another table, and then we give it a name as um, tweets clean. So every time we are going to query tweets clean, we are actually going to execute this query. Okay, every time we are going to, and in case we are joining tweets underscore clean with something else, then again this query will be executed under the hood. Okay, so views are quite important, and there is nothing much different from the standard Oracle views here. It's a similar one. Also also Hive lets you create custom functions. Okay, just like pig provided a way of defining functions. Okay, it also helps you defining your own function. Say for example you want to define your own lower function, lower as in which converts the text into lower. Although it's very trivial, it's already there. Lower function is already there in Hive, but in case you want your own kind of a function which is not there, you can define it. You create a class called lower, extend UDF, and then define a function called evaluate. Then you can use it. Right? And once you have defined it this way, then I mean, basically, for each function, you will have to create a class. It's as simple as that. Okay? Once you have defined it, you create a jar out of it. You create a jar out of it, and once you have created the jar, add execute this command called add jar your jar, and then you load this. Okay, and you, you want me to demonstrate it? Let me see if I have an example ready. All right. So Manish's question is that access controls on tables and views. So access controls are in a rudimentary state. Okay. And by default, by default, it is based on the user ID. It is based on the user ID. In case there is a basically the it's based on the users, and it's not that evolved yet. Okay. So tables are not shared across the users. All right. So let me just check if I have an example to show to you. So this is how you define your, okay. So let me try to create so you say file, export, jar file, and then you, okay. So let's call it, all right. So now this is on my local computer, and all right. So we have on my local computer, this my desktop, we have got downloads, okay, and so we say SCP, we say Hive. Let's rename it. I think I have already created SCP Hive UDF to Hadoop to student at Hadoop1 dot no big data dot com colon asgiri. Asgiri is the folder in which I'm copying the file which I just exported. Okay. Can we use the same scp command to copy over the files to Hadoop? Actually, the only thing which will differ is your source one. I have this file, you may not have the file. Also, the other thing will differ is in what folder do you want to copy. Right now, I'm copying to a folder called asgiri. You will have to copy it to something else. Okay. Okay. We say hi, add jar hive udf dot jar. We go to asgiri first and then run hive again. So what all we have done? First, we have taken run our Eclipse. In Eclipse, we coded our class called lower using this. And in this example is available on the page also on how to handle Hive. It's this example is available as a project also on that on the Hive page. And we say add jar hive udf dot jar. So added resource, it says, to the class path. The next step to define your own function is, so now your jar is loaded. The Java code which defines the function is now loaded. Now you can define temporary function called myLower using sg. Our namespace name is sg. You can see that here, package called sg, and we defined it. All right, and to test it whether it's working or not, we can select my underscore lower, and we can call it. Okay, so let me just make something capital. Okay, so here I'm not calling it on the top of any table or anything. I'm just for the example sake, I've done this. All right, so it has converted my word into lowercase, okay, using our own function. You could test it doing something really strange, and then you can see. Okay, so we were able to successfully code our own function which we used in our query. Now this function my underscore lower is just like any other function, like sum or lower, just it behaves as if it's a defined one. And using add jar, you can add any kind of code onto Hive. You can this actually helps you customizing Hive, right? Alright, so similarly, in case you are trying to load a JSON formatted data, you can add this library called JSON SERDE binary. SERDE is basically called serializer deserializer. So when you are loading from various sources into this database, so which is not something Hive can handle, you might have to write serializer deserializer. What does it mean by serializer deserializer? Converting serialization is converting in memory objects the into the bytes which are written to the disk, and vice versa. I mean, it all serializer helps you serialize your data, which means your objects, whatever they are in the memory, can be put into the disk. That is serialization. Deserialization is the data which is lying there, bytes which are lying there on the disk. To convert those bytes into a object representation or any value representation in the memory is called deserialization. Okay, so the way we just defined our UDF, in the similar fashion, by extending serializer deserializer, we can define our own way of loading data or understanding data format from understanding data format in our custom way. Okay, So some people worked on it, and some people also provided us a serializer, deserializer of JSON format data. So we can load JSON formatted data onto the into a Hive, okay, and using this particular library. So whenever you have to handle JSON data, download this library, add that to Hive, add jar and the and JSON library, and then you can do a create table, and then you can say row format is row format surday is this. Okay, this is the class they have defined as serializer deserializer. Okay, so this is the syntax row format serde, and then you can define a class name. All right. So this way we will be able to handle the serialization deserialization. Yes. So yes, very good point, Manish. So JSON can be nested as in one variable can contain another. And how do we define those mappings? So that mapping is basically you define it as a map. Okay. So whenever you see that there is a nesting of objects, so you generally define it as a map. Okay. So in the column definition itself, you can use those. And also have a look at JSON Survey library. Okay, you can have a look at JSON Survey library, or any serializer deserializer you are planning to use. You can look at their manual and start using it, right? So you can see this here. First column is a boolean, while second column is an array of strings, and third column is a double, fourth is a string. Okay, and they have defined this in this format. Okay, and in the nested structure you can see here you can use this one. All right, there are arrays, there are maps of arrays, and so on, right? So in case you encounter nested structures, you can use the complex data types to handle that. All right, great, great. So there could be many serializer deserializers in for your cases. So you can use them easily. Just download those binaries, copy into the same folder from which you are launching Hive, and then use a command called add jar and add that jar. Exactly the way we did our Hive UDF. We copied the jar onto our mm, Hadoop one. From there, we did a add jar after running Hive, and then we basically loaded the data using that one. Okay. Now there are few more concepts which are useful. One is order by X. Order by X is standard SQL, which we all know. Whenever we want to, I'm sorry. So whenever we want to order our data, we use order by. But the problem with order by is that order by is not distributed. Order by basically passes the whole data through a single reducer, which is not a great idea. Okay. So the general idea is that we use a command called sort by in conjunction with order by. Okay. Sort by X basically runs runs our sort on each of the reducers available for our query. For all n reducers, we are going to run the query. Okay, each reducers Each reducers might be receiving overlapping data, and that will be merged by the order by. So you generally use sort by and order by in conjunction. If you use only sort by and you don't use order by, there are chances that the overall data will not be sorted, because each data which went to one reducer is sorted in itself. But when you combine the two data sets together, that combination is not will not happen properly. That is what is ensured by our order by clause. Now there is a command, there is a command called distribute by also, which means will for each of the n reducers will get non-overlapping ranges of a value. If we are distributing one value, all of the reducers will get mutually exclusive portions of the data based on that particular field. Okay, mutually exclusive ranges of x will be availed to each reducers. It doesn't sort the output of each reducers. Okay, so you will only have n separate files. Okay, now when you have n separate files, you can use order by. So effectively you will have to use either, you will have to use distribute by x as well as sort by x, which means that your overall data will be sorted, because distributed by x made sure your data is mutually exclusive, and sort by ensured that your each exclusive data is sorted, and hence your overall result, if you combine distribute by and sort by, your overall data will be sorted. While cluster by X basically does the same thing, combination of distribute by and sort by. Okay, so if you have got n reducers as per I mean n is decided by Hive based on number of nodes available, and you can also define n using one of the environment variables. So all of the reducers will get non-overlapping ranges in case you are using cluster by, and all of these separate data will be get sorted. And this is the best way of sorting your data in case you have got multiple machines or hundreds of machines containing your data. Okay, because if you use order by will force the whole data to pass through a single reducer, which is not a great idea. So cluster by X is a better way of sorting the data. All right. So yeah. So as a quick demo, I mean, here is your table. Let me just define a table. Use 6 December. All right. Good. So we created a table called user ID, movie ID ratings, and at what time the ratings were given. We also download this data. I have already downloaded this data for in my folder, and so okay, so I'm going to download. Let me, okay, and then I run Hive. Okay, so I already have this data lying somewhere. Okay, so I don't have to actually download this data. Here it is. So we have got ML 100,000 ratings. Okay, so what we are trying to do is we are trying to load the movie lens data. Movie lens is basically movie rating data. Okay, use 6 December, and let me create this table. Oh, we have already created. Good. And we have downloaded this data already and unzipped it somewhere. And then we have, right? We are going to load this data. So when you download this data, given this URL, you will get this folder after unzipping it. In this, the one which is interesting to us is u1.base, okay, or u.data, okay. Under this u.data, I'll show you u.data. All right. You'll see that there are four columns. First column is the user ID. Second column is the movie ID, and how much this user has voted for this movie. That is the rating, and then at what date did it do that? Okay. It's a it's a millisecond representation of the time since epoch. So what we're trying to do here is we are trying to load this data. What is this folder? Okay. We're saying load. Let me just copy paste this. What is wrong with this? Home student. Home student as Giri. Home student. Okay. Home student as Giri. This is right. Load data local in path. Home student as Giri. Okay, let me see what is into table u.data. Table not found u.data. Use 6 December. Why table is oh this one. Okay. You're right. Thank you, Vishnu. All right. Select star from. Okay. So our data is loaded now, and you can do a lot of queries on this data. Okay. Say for example, in our case, we can write All right, we can write this. And also we can do things like select user ID. So let's have a look at what does our table say and describe this. So we say select user ID, comma, count of movie ID from our table group by user ID. Okay. All right. So what we're trying to see is how many each user has voted for how many. All right. So you can do a lot of things now. Once your data is represented in the form of table, you can do a lot of things. And it is, as you would notice, that this is far easier than actually writing MapReduce for the same thing. Okay. So most of the heavyweight lifting is done by Hive to convert any of your demand into a MapReduce. How can you suppress all these details that come before output? Okay, that is something we need to figure out. There would be some environment variable. So you can see that these are so each of these users, so 932th user has voted 241 movies. Oh, and so there are lots of people who vote for lots of movies actually. Okay, good. So how can we suppress all the details that come? There would be an environment variable or the command line. I think command line of Hive has a command called command line Hive has got command called uh, ver- verbose. I think we can do all right. So there should be a configuration. Okay. Okay. So you can put silent on the command prompt, and then most of these the error message, right? You or debug message you see, you can avoid that. Okay. All right. Now, so that was about Hive. So as an assignment, there are two assignments as part of Hive. First one is for each movie. Oh, okay. You do one thing as a quick demo. You try to find out for each movie how many users actually voted for it. Okay. And for each movie, what is the average rating? All right. And this is important. This is actually pretty straightforward. Just load this, and once you are done with it, just send me a query for both of them and with with the small results. Okay. So for each movie, how many users voted for it, and for each movie, what is the average rating? Okay. Now, other than this, go through your my courses. Okay. Go through your my courses here, and under the my courses you will see, right, under the my courses you will see the assignments. Here there is a Hive quiz. Please finish that Hive quiz on under session 7, which is today. And also Hive, all the steps are available here along with the hands-on assignment. Okay. So please finish both of that so that we can discuss it further, and this will actually strengthen the way you deal with it. Okay. Now Vishnu is asking about H catalog. H catalog is essentially the way the Hive stores the metadata. Okay, H catalog is used in that. Right. So you can see our so H catalog is one of the Hive stores. Okay, for running Hive, you run basically Hive metastore, and in case your Hive metastore is not sufficient, Hive metastore is the basically catalog. Okay, and then yeah, right. So we'll go into a bit of detail about H catalog a little bit later. Don't worry about it. Okay, right. Let's meet after the break. But finish all the quiz as well as the hands-on assignment for the Hive. Okay, and if you have any question, feel free to. How about other SQL features like in yeah, those are mo- m- most of the like having, where, group by, all of those clause are applicable here. Okay, hive is a hive is a pretty good implementation of SQL, so it actually supports almost all of the features of SQL. Okay, it I think it supports the it's called ANSI 11 standard. Let me find that out. I think in one of the our slides also it is mentioned. Hive is basically a okay. It's not mentioned. We'll mention that. So it's a good enough implementation of SQL. All right. Okay, let's take a break of 10 minutes and come back at around 9:01. All right. Hi guys, I'm back. So before the session, we were talking about H catalog. H catalog is essentially a table storage mechanism because if you see that whether MapReduce, whether Pig, or whether Hive, all of them require a certain kind of a representation of the data in the tabular format to make it easy for the data churning to happen. So So this H catalog basically provides this abstraction of where is the file located, how are the columns, and all of this. So H catalog is essentially half of the Hive, okay, half of the Hive. Why I'm saying half of the Hive? The Hive, which basically takes care of maintaining the metadata and maintaining the, you know, maintaining the table structure. And the other half which is related to query DML. So DML is not part of the H catalog while DDL is, meaning alter table. All of those syntax is provided by H catalog as well to all other services. So people who are using MapReduce can use H catalog and use and they will all get the table representation. So that's what is H catalog. All right. Because everybody, including Pig, including MapReduce, everybody wanted to have a database view, relational table view, so of the data. So on top of out of some of the common features of Hive, it was made as a service to the other components so that they can start using these alter table, create the table, all of these features as an API the other people can use. Okay, that's what is known as catalog. Okay. Similarly, we have something called a web edge catalog, basically that provides a REST API to do all the kind of a DDL kind of data definition language operations that everybody can do over the S- REST interface. So that is Edge Catalog, which provides a web access to our Edge Catalog. And Edge Catalog basically provides a relational view to all the components by the way of API. All right. So you work on the assignment. At least finish the quiz quickly. Quiz has hardly 14 questions, and you don't have to type anything. It will take hardly 10 minutes to finish the whole quiz, maybe 2 minutes or 5 minutes. So, all right. So that concludes our session number 6. That concludes our session number 6. Now I'm moving on to NoSQL and HBase. All right, should I move on or do you have any questions right now? All right, all right. So only Abhishek and Anna is okay with moving ahead. Hi. So Manish, I haven't used Impala yet. Once I do, I'll let you know. Great, great. So now we are starting a very interesting topic called NoSQL and HBase. The NoSQL itself is an interesting idea, and is worth going ahead. All right. So so it's a joke on the NoSQL. And so, do you have any expertise in SQL? No. That means you are an expert in NoSQL. Okay. So basically, if you don't know SQL, then you can say that you know NoSQL. Right? So, uh, so what exactly is NoSQL database? What exactly is NoSQL database? In very, very simple words, a NoSQL database is a database designed for scale, and we had to let go of SQL constraints. Okay, that is what is NoSQL. And as a consequence, these are few of the features. And although some of these features are basically disguised as features, they were problems essentially, right? So so most of the NoSQL databases are bottom-up designed for the high scale, for the huge scale. Okay. And in order to achieve that, the only way forward was to do a distributed computing. And while they did the distributed computing, it became apparent that each row should be identifiable. Only then the data can be fairly distributed across the network. So there has to be some identification for each row, and that is what we call ID for the row. All right. Most of these databases are next generation databases. Some of them call, I mean, are name as they try to say that we are not only SQL. Okay. But the essential idea is that most of these databases were designed for scale, for distributed computing. And when they were designed, when people trying to design such kind of database, the only way forward they found was to let go of SQL properties. Okay, we'll talk about what properties we had to let go of. And these are non-relational. These databases are non-relational, which means that the they cannot have foreign key constraints. They don't have, they cannot guarantee the 100% acid properties. And so who all know what is acid properties? Quickly, what does it mean by acid properties of a database? Atomicity, okay. A for atomicity, C for consistency, okay. Isolation, durability, excellent, excellent, great. So these acid properties of the database was the the most important thing in the database, and those things had to let go of when designing this new generation of databases. And actually, most of the NoSQL database don't even qualify to be the database. They are more like data store. Okay. Even HBase is also considered as a data store rather than a database. And most of these databases are open source. Okay. Why open source? Because If the database is not open source, the adoption goes really bad. Nobody wants to use a closed source database anymore. Gone are those days when people adopted Oracle. Oracle was early mover. If you are building a database and it's not open source, nobody is going to use it. Why? Because if tomorrow this company who provided us the database, the company shuts down, what will happen to their data? Okay, if it is open source, at least there is some hope. At least there is some hope that if it is open source, then and company shuts down, we have the source code of the database and we can use it. If it is a closed source database, it is going to be a disaster. All right. Now, most of these databases are schema free in the sense that they don't put a very rigid constraints of schema onto the database, meaning two rows can have different set of attributes. Okay. Unlike in a relational database, and most of them provides a easy replication. They provide a simple API and they manage huge data. And most importantly, all of these databases are designed to run on commodity hardware. Okay, almost all the components which claim to be distributed in architecture, they all try to be as distributed as possible and try to run on commodity servers. Commodity hardware does not mean that it's a very low end hardware or it's a very old hardware. Commodity hardware means it's a decent enough hardware which people use in the decent enough configuration. uh, okay, it's not server scale kind of hardware, which means it doesn't have 32 GB of RAM. Okay, and there are hundreds of NoSQL databases as of today in the market. All right. Now, why do we need such kind of a database out of nowhere suddenly? Why do we need it? Right. So, basically, when the big data comes into picture, we require distributedness. Okay. So, most importantly, all of these NoSQL databases are designed to handle the big data. Okay, high availability, as in there are millions of users hitting your web server, and in case you cannot provide availability, then your servers are of no use in today's time, because it takes a minute for your website to get a really huge load. Say, for example, you launched a service and your service got covered in TechCrunch. Okay, and or it got covered on Slashdot, you will get billions of users out of nowhere in a couple of days. Okay, so availability has to be there whenever you are designing anything. Third is scale out architecture, which means that in case you have to in case you have to add more machines, it should be easily able to extend the database to this new machine, rather than uh, you know uninstalling everything and then doing all of the magic. Ideally, the database should automatically expand to the new hardware which we are adding, right? So that is the reason. Those are the three basic reason: high availability, scale out architecture, and big data. Essentially the distributed computing. That's the only reason why we want NoSQL databases. All right. So There are various kinds of NoSQL databases. First one is column oriented or wide column. These are the databases, they look like your standard relational databases. And also, they also provide you JDBC kind of access or ODBC kind of access. And some of the examples are Cassandra, HBase, and Accumuloville. And essentially, these are column-oriented database or wide column databases are most close to our standard relational databases. We'll talk about it in detail. We'll talk about HBase in detail in the second half of the session. Then there is something called document-oriented database. What is document-oriented database? These are the databases which store hierarchical model of the data. Okay. For example, for example, we have TV shows. TV shows contain seasons. Seasons contain episode, and episode contains each episode contains reviews and cast members. Okay. So such kind of complex structure, which is sort of object oriented in the way that one object inheriting the other one, and so on. So such kind of databases are known as document database, right? Document database, or they are mostly like a object database. The examples of a document oriented database is MongoDB, CouchDB, and others. All right. Now, then there is something called key value database. Key value databases, key value NoSQL stores. These are the ones which were invented first. Okay, just to handle the complexity of the data, people thought that let's just have less of a structure and more of a distributedness, and that's where the DynamoDB was invented. DynamoDB was invented by Amazon to handle huge load that happens on Christmas. Okay. So because of the Christmas Eve, they had to figure out how to handle that load. And DynamoDB was the initial sketch. Now they have also moved on to the document kind of a database. Basically, DynamoDB itself has evolved into something else now. So similarly, we have Redis. Redis is also key value database, just that Redis stores the data into the memory. All of the data has to be in the memory, although this memory is backed up onto the disk, but all the data has to be in the memory. All right. The fourth kind of NoSQL databases are graph. Graph is essentially a database which contains the connected set of pieces. So document is sort of a tree kind of database where one object has another, and so on. While graphs are far more complex than this. Imagine that you have to find some correlation onto Facebook graph. Okay, Facebook friend graph. That those are the times when you use the graph kind of databases. And examples of graph database is Neo4j, OrientDB, and Virtuoso. So Neo4j is something quite popular, and there are GraphX which is coming from Spark. So all right. So any questions still here? Good, good. So this is the general standard summary of NoSQL versus SQL. SQL's the standard SQL like Oracle, they were invented in 1980s, and based on a person called Cod, his model. And so development started in 70s. So Oracle became quite popular in 70s itself. I mean, they started in 70s. And NoSQL databases, they were started in 2000s. Examples of SQL databases: Oracle, Postgres, MySQL, while NoSQL databases: MongoDB, Cassandra, HBase. And data storage model in case of SQL database is relational, and in case of NoSQL, it varies based on database type. Okay. Schemas, in case of SQL database, the structure and schema is quite rigid, and you need to define your table upfront rather than adding more columns later. Okay, so two rows have to have the same set of columns, right? Now, generally, the NoSQL databases have the dynamic one. So why Pig and Hive is not featuring on this list is because Pig and Hive are not Pig and Hive are not really a database. Okay. Hive provides you, because Hive even doesn't provide you a way to manipulate data. You can't even do an insert and update. Okay. So Hive is more like an analytics, I mean, platform for analytics instead of providing you a way to modify the data. Okay. In case of Pig also, the objective Pig doesn't even have the backend. It is just a client. Doesn't even have a server. All right. Now, so Pig or Hive do not qualify to be the database. Scaling in case of SQL database, it's vertical, while in NoSQL database, it's horizontal. What does it mean? When you try to upscale, when you try to, when you your business user or your end user demand a higher load, then what do you do? Okay. So ideally, what people used to do is they used to just increase the hardware and then move on. They increase the hardware, then move on. And but that is that kind of increasing the hardware. Earlier we had like 10 GB, I mean 8 GB RAM. Now we increased it to 16 GB. Or earlier we had one core, now we have got dual core or quad core. This is called upscaling, or this is called vertically scaling. Okay. While if you add more PCs or more computers to cater to the demand or cater to the load, then we call it horizontally scaling. Okay, horizontally scaling. As you saw in this diagram, right? In this diagram, this diagram shows that this cart is horizontally scalable. Okay, whenever load is increasing, okay, whenever load is increasing, we keep on adding kettles to more kettles to pull this cart. Okay, that is called horizontal scaling. Instead, if we remove these buffaloes or remove this cattle and put horses, or if we put camels, or we put elephants, or maybe we wait for putting dinosaurs to pull this cart, then we call this vertically scaling. Okay, so I guess this example should give you a clarity on what is vertical scaling and horizontal scaling. Okay. The development model for almost all SQL databases was earlier closed source. It's just that later point of time, the databases which started coming in 90, after 90s, they were mostly open source. Okay, so there was a mixed model. While NoSQL, all of them are open source. So SQL database support ACID properties of a transaction, while only few, or there is no such guarantee from NoSQL databases. In SQL databases, the data manipulation language is some variation of SQL, while in NoSQL database, it depends. Each one has their own kind of a API. Okay. Almost all RDBMS or SQL database has been designed for strong consistency. Okay. And in case of NoSQL databases, it all depends on the product, and it all depends on the configuration. How do we want to handle that consistency? Some provides you strong consistency, some provides you I mean eventual consistency. It all depends. Okay. Now, there was a reason why none of the NoSQL could provide you, guarantee you the ACID transactions, because there were constraints. So the moment distributed programming comes into play, lot of rules of the game changes, and we'll talk about it why. So Cap theorem says that there are three things you cannot provide simultaneously. First one is all three things cannot provide. At most you can guarantee two of these, but not all three. What are those three criteria? First one is consistency, availability, and partition tolerance. Out of C, A, and P, you can only have two. You cannot have all the three. We'll see couple of examples so that you understand this one. So what does it mean by consistency? Consistency means that all the nodes see the same data at the same time. So all the clients of your database should see the same data at the same time. That is consistency. Okay. Availability, the guarantee, the guarantee that every request receives a response, whether successful or failed, that is another deal. But every request should receive a response. Okay. No request should go unanswered or should get dropped without getting an answer. So that is called availability. That is called the guarantee of availability. All right. Now, third one is partition tolerance. What does it mean by partition tolerance? So, in a network, if you shut down any computers and none of your system gets impacted, that is called partition tolerance. So at any moment of time, if you shut down any computer and your system is running very nicely and happily, and still, although you have shut down one of the nodes, that is called partition tolerance, ability to tolerate the failure of few components in the network. At least one component, at least one computer should be able to handle. Okay, so that is called partition tolerance. So Cap theorem says that out of these three guarantees, none of the databases can guarantee all the three. None of the databases can guarantee all the three. And let's see why. Okay, let's see the first architecture where there is a single machine. There is a single machine, there's a reader, there's a writer, all are talking to the single machine. While writer is writing something, all readers are waiting in the queue, and similarly, while readers are reading something, writers are waiting for the queue. Okay, so this system was great. This system was great. It was consistent. It was really nice. Okay, the only downside of this system was that it was not available, meaning in case there are too many users, lots of the requests will go unanswered because there is only a single node, and every single node has got its own limitations. Third, partition tolerance is not there. In case this computer shuts down, none of the users will be able to read or write. Okay, although data might be intact, we might have put RAID onto this machine, but it's not available. Users are not able to use your database. Okay, The second architecture, you can see that readers are reading from one system while writers are writing into another. Okay, so writer writes to one system, data gets replicated to another one, and users keeps on reading from the another one. Okay, nobody writes to more than one node in this kind of architecture. All right, so what happens here? So is it consistent? No, it's not consistent. Why? Because user wrote just now one particular data. Now when it started reading, it read from another machine, which means that the data it's going to read is older one, not the newer one which it just wrote. And from its perspective, the data is inconsistent. I wrote something else, I got something else. Okay, that is inconsistent. All right, because it would take some time to propagate what I wrote to the machine from which I'm going to read. And that is why we call it that such systems are not consistent. But good part is, but good part is that such systems are available and such systems are partition tolerant. Most of the big data solution are like this. Okay, most of the databases are like this. Okay, be it MongoDB, be it others, though they have a guarantee, but still there is a consistency missing at lots of phases. All right, and so most of the NoSQL systems, they follow a paradigm called eventual consistency. They are not immediately consistent, but they are eventual consistent. Why? Because since the replication is happening and write is happening only on one system, eventually everything is going to be consistent. All right. Now there is a third architecture which is also quite popular. In this architecture, you keep on reading writing to one and you have a secondary node which keeps a mirror of this one. So at a time only one system is serving reads and writes. Okay, while the second one is in sort of a zombie mode which keeps on copying the data from the one which is live. Okay, now this system is consistent because people are reading to the same machine and writing to the same machine, but this is not available, though this is partition tolerant, meaning the moment one node fails, immediately the second node will be placed and users will be talking to the second node. Okay, so this is consistent but not available. Why? Because all the users are reading writing from the single machine. So you can clearly see that it's not theoretically possible to have all the three C, A, and P consistent, available, and partition tolerant system at the same time. Right? Sounds good to you? Any questions on this slide? No questions? Did I explain? I mean, either I explained well or I confused you all. So, all right. Good, 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 good. Great. So basically, we are able to. I'm trying to give couple of examples. You guys can also come up with few more examples of architecture. All right. And most of the architectures, they try to address these three scenarios, but most of them, they are not able to do that. All right. Now, So this is the typical story anybody who becomes popular goes through. Okay. So if you're launching a website which is going to become massively popular, these are the phases you are going to go through. So you go through the moment you have this initial public launch. Okay, and this is actually a story of most of the companies in since 2000s, last 10 years. So they go for an initial public launch. So they move their you know application from local machine to a shared machine to their server which they have just purchased. It's great. Everything is just perfect, well defined schema, all the indexes are ready, our database is perfectly in place. Now service becomes popular and too many writes are hitting, too many reads are hitting the database. Every time our user is requesting something, we are going till the database and giving to the user. Now now you realize that why can't we just cache the data in between? Because reading from the file system or reading from the database is quite expensive task. Why can't we just keep the things which are required frequently into the memory? And the moment you do that, or this is also called caching. So the moment you started doing that using a distributed cache or using a RAM or using other things, your data is no longer, this is no longer, since you are caching, there is always a lag between cache refresh and the data change, which means that you might be catering to the user a stale data, right? There's a high chances, there's a very high chances, and therefore you have started to violate the acid properties of the transaction. You have started to violate the acid property. The moment you start caching, your acid properties are no longer guaranteed, because you are serving a stale data. This staleness might be 1 millisecond long, 1 second long, or it could be few minutes long. Okay. And the moment the more you optimize, the more you will realize that you are hitting to the on the acid properties of your data, right? You are hurting it. Now, because, all right. So memcached, in case you don't know, memcached or a redis are these good solution for caching the data. Now service continues to grow in popularity. Now, too many writes are hitting your database. Too many writes are hitting the database, and service is growing in popularity. Now, what happens in these circumstances that when, since you were you try to optimize reads, now next thing, the moment traffic goes up, you will have too many writes. Now, if you have too many writes, then what will happen? When there are too many, you were able to handle reads, but the moment writes are increasing, you would not know anything other than just increasing your hardware at this step. You'll say, okay, now let's just buy 200 GB RAM and put it onto this computer. Put more, like put 32 cores, put 16 cores, put 15,000 RPM disks. Okay, so that our writes become faster. But then that is not sufficient. That is not sufficient. Soon enough, you will realize you have lot of new features coming in. uh, as your service grows in popular, you'll have more features, user demanding more features, your product managers coming up with new features and adding all sorts of ideas and experimentation, and your queries soon start becoming new joins. Imagine this. So your product details page, or say when you are going to Amazon, you have so many parameters starting with title, who is the author, how many authors, who is the first author, second author, and so on. More and more features you are adding, reviews, ratings, everything is coming up. Every new day you have more features. Now, as the features grow, to generate a single page, you might have to join on all of these tables. Generally, each feature results in at least one more table. And effectively, for serving a single page, you will have hundreds of joins. Now, what? Now, what should we do? So we realize the only way to go forward is, let's do denormalization. Okay. Because rather than looking up two tables, why don't we just copy the data from another table, and instead of referring it by ID, we just put actual value in this. Okay. Now at this point, if you are from DBA background, you will get irritated saying, "Ki, this is not what I learned in DBA school. At DBA school, we were taught to normalize our data, in not denormalizing it." Okay. So first, you let go of acid properties. Now you let go of normalization. And slowly, you will realize that the things which database flaunted as features, you no longer use any of those. Okay. Now further, if your server is growing further in the popularity, okay, so you stop doing the server side computations. Forget about doing computation in triggers. Forget about doing computations on uh, I mean, instead of doing a lot of work on the server side, you start delegating a lot of work to the client side. If it is not required to be done on the server side, let's delegate it to the client side. Okay. Server should behave like a simple database. All right. Now, still, lots of queries would be slow at this point of time. So what people do in these scenarios is we pre-compute or pre-materialize stuff. And pre-computation is a huge game. At least at Amazon, where I was working, we used to do a lot of pre-computation. Even the image which we show at the product details page, these are all pre-computed for all the devices and for all kinds of users in all territories. Okay. So we start pre-materializing a lot of stuff we start pre-computing. Okay. And we try to avoid joining the data as much as possible, so that our queries are really fast. Now now at this point of time, you will realize that the reads are okay, but writes are getting slower and slower. Now what will you do is you will start dropping secondary indexes, and that is where you will get psyched that we let go of acid properties of the database. We let go of the because we let go of consistency. Then we let go of all our triggers, we let go of denormalization, and we let go of secondary indexes. And then at this point, you start questioning that why do we need a database then, when we don't need these features? And that is the reason why the whole NoSQL was invented. All right. So the conclusion is, if your service is growing in popularity, you will eventually anyway let go of the properties which are not there in any NoSQL database. Okay. So and in return, you get distributed and scalability. All right. So the features which so the idea of this discussion was the features that database provided became a lot of pain when it comes to to handling a lot of requests. And that's exactly the reason why DynamoDB was invented in first place. All right. So let's talk about something called column oriented database. Before we move on to our HBase, we'll talk about column oriented database. A column oriented database is something where columns are stored first and then rows. Okay. What does it mean? Imagine that we have a table called having two columns, employee ID and name. Employee ID is 10, 12, 11, and each row is marked as 001, and the second row is 002, and third row is 003. Okay? So, in row oriented databases, the storage will be when this data is getting stored onto the disk, it is going to be in this order. First, the first row will get stored, then second row, then third row. And in each row, first will be the first column, second will be the second column, and so on. That is the kind of storage you have in row-oriented database. But, but in case of a column-oriented database, first the columns are stored. Okay, first the columns are stored and then the rows are stored. Like how? So first 10 will be stored, 12 will be stored, then 11, and then Joe, and then Mary, then Kathy, and sorry, yeah. So this is how it is going to get stored. So I hope you got the idea. What does it mean by column oriented database, right? So essentially, in column-oriented databases, the data which is in the same column will be in the store closer to each other. All right. Any doubts about it? No? Good. Okay. Okay. So Abhishek's question is, what are the advantages of columns oriented? We'll talk about it quickly. Okay. We'll talk about it soon. Don't worry. When we talk about HBase, we'll talk about it. Now, Now, the column family oriented databases are one step ahead of column. It's a mix of both the worlds, column oriented and row oriented. Now, in column oriented database, okay, let me. So, the biggest advantage of a column oriented database might be when you have so many columns in the database, you can divide them easily. You can divide the data easily onto multiple computers because one column gets stored at one machine, second column gets stored at second machine, and so on. So that's the advantage of having a column oriented database. But neither of these are sufficient when it comes to storage and distributing a table across the network on multiple computers. Neither of the mechanisms suffice. Neither the column oriented strongly column oriented database is sufficient, nor strongly row oriented database is sufficient. The somewhere between the two is what works out. So that is what is called column family oriented database. Column family is like a huge table containing multiple sets of columns. Multiple sets of columns. Okay. Column family is column family is a collection of columns whose data is stored together. Okay, whose data is stored together. So in a column family, although the data inside the column family gets stored like a row oriented database, but a column family, the data in a column family is always stored together, which essentially means that it is easier to store the whole column family onto one machine and the other column family onto another machine, and that's how HBase stores the data. Okay, so each column family is further divided into row sets and so on. Okay, so column in a column family in a column family oriented database like in this one, So name and age belong to the same column family. Sorry, in this example, the employee id and age, sorry, employee id and name belong to cf1, and cf2, which is column family 2, contains only age, and therefore you can see that 001 contains 10 comma Joe, then 002 12 comma Mary, and then 11 Kathy, and then comes 23 33 45. Okay, so 10 Joe, 12 Mary, 11 Kathy, so they are all column family gets stored first, then second column family gets stored. Okay, that means it is easy for column one column family, it is easy to divide the tables into column families, and each column family stays on one computer. Okay, we'll go into the more details about this. All right. So what exactly is HBase? HBase is a column family oriented database. Okay. It has got CP out of CAP, which means it is more focused toward consistency and partition tolerance. It does have a bit of availability issues, but that is tolerable. So, as a part of design decision, they favored consistency over availability. Okay, the whole design of HBase was based on Google's Big Table. That was the third paper Google published after MapReduce, HDFS, and MapReduce. It is great for hundreds of millions or billions of rows. If your data is smaller than that, you should better be happy with your MySQL. If your data is growing beyond, if it has rows more than hundreds of millions, or if then it makes sense to go for HBase kind of a database. It is not eventually consistent, it is strongly consistent. So automatic sharding. Sharding is what? Sharding means division of data across the cluster. The division of data across the cluster is called sharding. Okay. When we say cluster, cluster means multiple computers connected to each other. Okay. Now, automatic sharding means that division of data happens automatically, and the data gets distributed across the network automatically. All you focus on writing into your table, and it will automatically get splitted across the network. Okay, and there is automatic region server failover in case one of the, okay, we'll talk about region server. Each data is divided into regions. Whole table is divided into regions. First, the whole table is divided into column families, and each column family contains multiple regions. And each region I mean, each column family contains regions in the sense that a region means a set of rows. Okay, so these regions get spread across to various machines called region servers. Region servers are basically HBase's data store where the sections of the table get stored in HDFS. Okay. Each region server is running on generally on near the data node, and the actual data gets stored on HDFS. All right. Now, so in case one of the region server is the one which stores regions is a part of the single column family. And in case one region server fails, there is an automatic failover. Okay. Because each region will be stored in HDFS, and that has got a copy, and automatically region server gets shifted in order to in order to tolerate the failover, to tolerate the failure. It has got a strong MapReduce and HDFS integration, meaning that when you can query the HBase table using MapReduce, as well as you can use HBase table as part of your MapReduce program. You can read from HBase and write to HBase. All right. Because it provides you the support of MapReduce. It by default give you massively parallelized processing. Even if you have 10,000 computers running HBase, you can easily run your MapReduce and get the results. That is what we call massively parallelized processing. Okay. So API and thrift. So the way we talked about Hive, and when we talked about Hive, we talked about thrift. Okay, so thrift is one way we can we provide the API in almost all the languages. Rather than writing your API in Java, C, C++, you should write your API using a service layer called thrift. If you intend to provide a uh, global library set, okay, in case you intend to provide your library in almost all programming languages, then you should think about using thrift. Okay, similarly, uh, HBase also uses the thrift for for providing the API, and it is needless to say that it provides you the API in Java. Okay, and there are a couple of interesting ideas like coprocessors and Bloom filters, which help you make HBase really powerful for doing parallel processing. Okay. Having said that, HBase is still a sort of a data store. It does not have a proper SQL query language. Okay. It only provides a rudimentary API using which you can write to the table, read from the table, scan the ranges, and so on. But it does not provide you full-fledged SQL queries. Okay. Queries you generally use Hive or Pig, and there you use HBase connector to read the data from HBase. Okay. Okay. Silpa's question is the way we mentioned in the second class, if we are using a scoop, we can import SQL database into Hadoop. Okay. That is HBase. Will the transactional properties continue to exist here? The answer is no. None of these databases provide a transactional properties as yet. Although they do guarantee some sort of consistency, but this consistency is only row level. Okay. So whenever you are editing a row, there is a guarantee that there is a consistency on row basis. It's a very good question. On each row, there is a consistency, but the kind of consistency we had in case of a transaction is not here. Meaning, say you have a transaction having row commits into multiple tables or multiple rows in the same table or a combination of both. That kind of transaction where either this row, that row, and these tables get done or nothing gets done, that kind of functionality or transaction is not provided by any of these databases, including HBase. But HBase at least provides us the row level consistency with which we can emulate a lot of things, but it's not that clean. All right, good. So that is what is known as HBase, and we'll go around into more details in the next session. This is good enough for today. Please finish your all assignment of Hive as well as Pig as well as the earlier ones. Okay. And some of you have submitted the assignment. That is good. Some of you are still pending. So please at least work on the objective questions, finish the objective questions. And those who do not know yet, all of the you should log in onto the website, go to my courses. Under each sessions, everything is available, including this presentation. Okay. So this presentation, today's presentation is available on session number 7, and quiz is also there, Hive quiz in today's session. Okay. And yesterday's session we had assignment, hands-on assignment, and so on. All right. Yeah, you can download the presentation, I think. I think you can download, you can say click on open. Let me see if I can. Yeah, you can download from here, na? Here, this button is there, download. Okay, you can download, there's no issue. All right. Feel free to, I mean, if you have, you can reach out to me. And the general communication, you just drop an email to hadoop@nobigdata.com. Okay, me or somebody else will quickly reply to you. Okay. All right. So yeah, we'll see you on the next weekend. Next weekend, and we'll go into H details of further details of HBase, and we'll also talk about something interesting called Zookeeper, and afterwards we'll go into Flume, Scoop, Uzi, and then we'll talk about Spark, Storm, and Mahat. Spark will go into more detail this time. Okay, Spark will go into more details, while Apache Storm will just touch base on the introduction, and we'll go into one of the Mahat's example end to end, and we'll compare the technologies. Okay, so that's the plan. All right, that's the plan. So there are a lot of things coming up, and so finish your all quiz. Otherwise, it will be too late. You will be burdened with lot of data. Okay, lot of questions. All right. So stay connected. If you have any doubt, just drop me an email. I try my best to respond quickly. But sometimes I do get overloaded. Yeah. So feel free to get in touch and stay connected. All right. Thank you very much, and see you next week. Bye bye. Have a good day.